Hello and welcome to my channel. Here we will have high quality physics videos especially for NET, GET, JEST and all the similar examination. So in this video we'll go through the CSIR UGC NET 2019 June physics paper solutions. So this will be a 55 videos for 55 problem series. So stay tuned. You can go through the playlist to see more of the videos of the same paper. Okay, so without wasting your time, let's jump into our question. Okay, so we have the question which goes something like this. The wave function of a free particle of mass m constrained to move in the interval minus L to L is psi x. Okay, and psi x is given by a L plus x L minus x, where a is the normalization constant. The probability that the particle will be found to have an energy is, so we have 4 options. So we need to solve this problem. First of all, as you can see is, for a free particle of mass m constrained to move in the interval minus L to plus L, so how does the well look? So it is said that it's minus L to plus L. So imagine that the well is something like this, where this is minus L, this is plus L. And we know that the wave function looks something like this. So psi n is 1 by root L cos n pi x by L, n pi x by 2L, because the length is 2L, where n can take 1, 3, 5 and so on. And psi n can also be 1 by root L sine n pi x by 2L, and here n can take values like 2, 4, 6 and so on. If you want, you can also represent these the energy levels in this fashion. So this is minus L, this is plus L, and let's say I have these levels. So this is for E1, this is for E2, this is for E3 and this is for E4. So how does it look? So E1 will look like this. E2 will look like this. Similarly, E3 will have more curvature, and then E4 will have 4 loops. Okay, so this is how the energy looks, and of course the energy is given by n square pi square L square divided by 8m L square. So this is the energy, the nth energy level of this well. Now we are given with the wave function as a L plus x L minus x. Okay, and the energy is given by pi square h square by 2m L square, which you can write as 2 square pi square h square divided by 2 square into 2m L square. So why we are writing in this form? Because we need to use En to get the value of n. So for that we need 8 at the bottom. That is why we multiplied by 2 square. So here, as you can see, n is 2 in this case, because this will be 2 square and this is 8 ml square. So basically n is 2. Now after this, what should we do? Now we came to know that the value of n, the energy level, is 2. And we also know that the wave function for E2 will be something like this. Or the 2 gets cancelled, so it will be sine pi x by L. Okay. Now we all know that probability is calculated as psi and then we have this square. Once again we'll go back to the question. It is said that the wave function of a free particle of mass m of the given wave function, where a is the normalization constant. Okay, so this is the information. The probability that the particle will be found to have the energy is. So in the question the energy level is given. From the energy level we'll find on which excited state this energy is, and we found it is E2. For E2 we have the psi of 2, and then we are trying to find the probability. I hope that you got the idea how we are trying to solve. Now we are trying to find what is the value of psi 2, which we can write as minus L to L A L plus x L minus x 1 by root L sine pi x by L dx, which you can simplify as a by root L minus L to L L square minus x square sine pi x by L dx. You can break the integral into two parts, and you can write it as a by root L, open the bracket, minus L to L L square sine pi x by L dx, and you have the other integral, that is minus of minus L to L x square sine pi x by L dx. Now clearly you can see that something is very clear in this integral. This integral is an odd integral. Even this integral is also an odd integral, because we have x square which is even and sine of pi x by L is odd. So the integral will be 0 because it is running from minus L to plus L, right? That is why what happens is the value for psi of psi 2 is 0. Now when psi of psi 2 is 0, the probability will be 0. Why? Because this value is 0 as we calculated. So in the option, the correct answer is option A. That is, the probability that the particle will have found of the energy is 0. I hope that you have understood how to solve this kind of problem. So you have to be a little bit quick, especially in this section where while you are solving the problem in the exam. For that, you need to practice a bit of this kind of integral where you can identify which is odd, which is even, and easily calculate the values. I hope that you find this explanation useful for your understanding. Hello there. If you like our videos, do consider subscribing to our channel. It really helps us to keep motivated and create more. Thank you for watching. Take care.